forward as well. So without further ado, Chris, please take it away.
Thank you, Kimberly. All right. So hi, everyone. Like Kimberly said, my name is Chris Cogswell. Today we're going to be talking about helping engineering students advance their research and their careers. So first, a little bit of background on me so you kind of know where I'm coming from. So I got my Bachelor's of Science in Chemical Engineering and Philosophy from the University of New Hampshire before joining Northeastern University to get a PhD in chemical engineering. And you know, as an undergraduate student myself, some of the most impactful things that I had on beginning my career and also, you know, moving to grad school and being successful there and then going into careers was undergraduate research. And besides that, all the learning opportunities that I got outside of the classroom through research tools and information that I was able to get myself and all the mentoring that I got. And so when I joined Northeastern and began my PhD, I thought it would be, I wanted it to be a big part of what I did to mentor my fellow undergraduate students or mentor undergraduate students as well. And so actually, here are some photos of some of the undergrads that I had the pleasure of mentoring and working with during my time at Northeastern. At one point, our lab had over 30 undergraduates at one time doing different research projects. And so today we're going to be talking about how to help make that undergraduate research experience a little bit more effective and a little bit more impactful, but also ways that you can show students, if you are an admin or a librarian or someone who has, you know, people that you mentor, ways that they can use these tools, Engineering Village and Knovel, to not only learn new things about a subject, but also learn about, you know, companies maybe they want to apply to, schools maybe they want to do research at, and things like that. Okay, so just in general, how can we make student research meaningful? And this actually comes from a couple of research articles in Nature and Science. You know, the first one really is just be good mentors, right? Give good guidance by either PIs, postdocs, or graduate students. And the first way to do that is to really consider the students' long-term goals before you, you know, begin setting up a process for them to work with you. So are they interested in graduate school or are they interested in going into industry? And also think always, you know, not only how can having undergraduates work with you be helpful, but how can that research project be helpful to them, right? And one of the biggest ways that you can do that is by setting meaningful expectations and milestones. So what is really to come from this research? Do you want them to generate a report at the end of the semester? Are they going to do a poster at a conference or maybe a paper or a publication? But more importantly than kind of those, you know, solid results of research, what can they learn by doing research in your lab, or what can they learn by doing research as a student? And so some of those things that maybe you'd want them to learn are things like, you know, the ability to do a literature review or gain background knowledge, laboratory skills. Even if they can't do the experiments themselves, they can learn the skills that they need, and they can learn about the machines and processes you utilize. And of course, data analysis skills, right? Statistics, design of experiments, those sorts of skills that are really important out in industry that we hear a lot from our industrial clients. You know, the one thing that they wish is that when they brought in new people, they had those kinds of data analysis and design of experiment skills that they can then apply to their work. And so when we think about why, from the undergraduate's perspective, they get involved in undergraduate research, or why, if you're an undergraduate watching this, you maybe want to get involved. You know, it really helps you build a connection with faculty and the larger research community in a way that's not possible through simple coursework. It helps you learn valuable skills for industry and academia. It will help you learn how to engage in public discussions of research and learn how to present that research. You'd be surprised, but almost the most important thing you'll learn in school, outside of, you know, all the stuff you need to pass your courses, it might be PowerPoint and Excel, right? And how to present things using those tools. And finally, of course, it looks great on your resume. But some of the things to consider before jumping right into undergraduate research, or before having undergraduates in your lab or in your research group, you have to think about, you know, what is the time and energy cost? And really, with all of these things, you're going to get out what you put in. So do you have the energy and the time to dedicate to a research project? Do you, as an advisor or as the head of a lab or a researcher in a lab, have the time and energy to allow someone to be mentored by you or have someone be mentored by you? Furthermore, you have to think about the opportunities that they'll have in your lab itself, right? So is your research costly? If your experiments cost, a couple of $1,000s a run, you probably don't want some new trainee running those. If your experiments take a very long time to run, you also probably don't want students or others maybe causing an experiment to fail. So you need to put controls in that place. And of course, safety concerns, right? If you're working with solvents that are extremely dangerous, chemicals that are an issue, any kind of other safety concerns, you also have to take that into account. And so really, all of this comes down to the idea of finding the right fit. And so today, we're going to be talking about kind of two general areas. The first is how do you find the right fit, either as an undergraduate or even as an advisor. So from the undergraduate's perspective, or somebody showing an undergraduate or a mentee how to do this kind of analysis, we're going to think about questions like who is doing the research you want to do, what research is of interest for you, what companies maybe are doing similar research to the work you're doing or the work you hope to do, what other schools do that research, and even what will you likely be able to do in this lab, or how are the other undergraduates' experiences in that laboratory. And the second thing we'll talk about today is how do you get the most out of a research experience, both as a professor or PI, but also as a student. So sometimes undergraduate research is frustrating, but even in those areas or times where it is frustrating, you can always have students reading and analyzing literature, learning about techniques or the techniques of others, and looking for further avenues of investigation or research. And I actually put this picture up here because I always thought it was really funny when I was a student. The lab that I worked in made metal organic frameworks, and so our experiments were costly and used some dangerous solvents and things, so we had to be really careful about training our undergraduates correctly and always being present when any experiment was being run. But a lot of the undergraduates that we had came from the bioengineering labs because the work that they were doing was mostly pipetting things. And some of my students loved that and thought the bioengineering research was worthwhile for all the great things you can do with it. And others wanted a more hands-on approach, right? So it really is all about finding that right fit. So today we're going to be talking about two specific engineering tools that can help us answer those two questions, right? How do I find the right fit, and how can I get the most out of my research experience? The first one we'll talk about is Engineering Village, and specifically we'll talk about Compendex. This tool will give you access to journal, standards, and conference proceedings that have been indexed in a searchable format, so you can really quickly answer those questions we highlighted. Knovel, on the other hand, will give you access to full text technical handbooks, best practices, and properties and materials data. That's going to help us answer some of those other questions about getting the most out of our research experience. So from the perspective of introducing this to undergraduates or people that maybe you're mentoring, Knovel has access to all of that full reference content, but it also has digitized tables and graphs of useful engineering info. So for example, material or thermodynamic properties. And it also has digitized and editable equations that can be really useful for undergraduate students. Engineering Village, on the other hand, has abstracting and indexing information, a numeric search that'll help you find the right information quickly, and the ability to filter results in different ways to analyze data in the most efficient way possible. And on top of that too, in terms of the users of the tool currently, you can see on here many of the universities and companies people would like to work for. And of course, we also have 150 plus different content partners. So not only are you going to be using a tool that you will also have available at a lot of companies or schools maybe you want to go to, but you'll also be getting information from the best sources and places that you can find. Okay, and with that, we are going to move on to the tool right away. So here is the main Engineering Village page. And so if I wanted to find the right fit, right? Let's say I'm a student and I'm interested in doing work at Purdue University. I can search for things in two different ways. The first one I can do is simply search here Purdue. But I can also go up here to search and go to my engineering research profile. Now if I click on that, and then I search for the institution that I want to look at, so Purdue, I can see very quickly their top authors, their main research focus, their funding sponsors, their publishing trends, where they're publishing work, and also the subject area of research work that's going on. Now, let's say, for example, I'm a student at Purdue and I'm working in the area of chemicals, or let's say nanotechnology maybe. I can click here on the tab for nanotechnology and see all of the research that's been published since 2009 from Purdue University's different departments. And so here I can see that if I wanted to do nanotechnology research at Purdue, that I would be looking at these authors, right? And so I can look at these in different ways. I can pull this out as a print or I can download it. I can also look at it either as a focus. So here, nanoparticles, graphene, nanotechnology, nanocrystals, nanowires, nanocomposites, basically everything with nano in front of the term. I can see who's funding their work, right? So I know that if I want to do nanotechnology work at Purdue, that I maybe would want to apply for a grant from the NSF or from the US Department of Energy or Purdue University itself, right? Now, if I found one of these that was particularly of interest, I could click in. So maybe I know that I want to work on graphene. So I can click on graphene here, and it'll build out the search for me, where I look at this as the institution ID for Purdue. It gives me the classification code, so graphene nanoparticles, and then the years that I want to do research in. And now I can go through this, and I can read the abstracts and see if anything looks of interest for me. But I can also look a little bit more deeply at the kind of content itself. So if I look at the facets here on the left-hand side, I can look, for example, at the country where the author is affiliated, and obviously most of those in the United States. I can look at the classification code. So within nanotechnology itself, some of the work they're doing is also considered to be semiconductor work, or electricity work, physical chemistry, material science, solid state physics, thermodynamics. I can also look more closely at the different controlled vocabulary terms. So we searched for graphene as our controlled vocabulary term when we clicked on that button above before. But if I look at what the graphene's being used for, I can see here graphene transistors, nanoribbons, molecular dynamics works, thermal conductivity, field effect transistors, substrates, phonons, chemical vapor deposition, nanocomposites, all kinds of stuff. Now maybe I'm particularly interested in phonons. So I'll click in this, and I can keep building out that search. Now I can do something very similar if I wanted to look for a company that maybe was doing this kind of work. So for instance, if I get rid of this search, let's open up a new tab here in Engineering Village. If I searched for phonons in Engineering Village, as in the expert search up above, I will get a tremendous amount of records. But now what I can do is start looking at author affiliations. So for instance, I know maybe that I want to work in the United States. I want to look at stuff that was published over the last couple of years only. So I can limit it to that. And now I can start looking through here and trying to find, are there companies that are doing these kinds of projects, right? So I can see, obviously I have a lot of departments and schools and things. However, here I have Argonne National Laboratory, right? Sandia National Labs, National Institute for Materials Science. So I know likely that if I want to do work in phonons as part of my career, first off, I'm going to likely have an academic career because that's where a lot of work is happening. But if I don't stay in academia, I know that I can work at national laboratories. And so I can start looking here now. So if I look at phonons and I look, say, for example, at Sandia National Labs, I can click here and I can find those top authors here. And now I have a list of names of folks that maybe I want to reach out to on LinkedIn, right? Maybe I want to see if any of these people have co-occurring citations or publications with people at Purdue, where I did this initial research, right? So you can really build this search out and get a lot of great information here that isn't possible in other places. All right. So let's say my dream comes true and I get a great job as an undergraduate working for a lab that's doing phonon work. Well, now I get there and I got to ask myself, well, what the heck is a phonon? Well, what I can do is go over to Knovel. So this is the tool where I said before we can get the most out of our research experience. So here, if I search, say, for phonon, okay, the first thing that comes up here is there's a lot of books and text content. There are some graphs and tables, but there are also definitions. So I initially don't know very much about phonons, let's say. So I'll click on definitions and see what the definition of a phonon is. So here, I can click on this. And here is my information. So let me zoom in here a little bit more. So phonon is a quantum of crystal lattice vibrational energy having a magnitude of hf, where h is the Planck constant and f is the frequency of the vibration. All right, maybe that brings up more questions than it answers. However, what I can do, I can add this note, say, and I can put here, right, this is for my Phonon engineering project. Add my note for myself. And here what I can do further is I can save this book to a shared folder. So here, if I make a folder called Undergraduate Research Core, which I've already done, but so I click on there, and then I hit save, this book now and this note that I wrote will be saved in that work. And so I can start building a digital library of information for my students to actually go through and read for themselves. Now, if I wanted to get a little bit more complicated besides just definitions, I can now here go through books and text, right? And I can see the kind of information that's coming through on phonons. I can look here at the types of stuff that is co-occurring with phonons. So seeing boson, graphene, quantum dots, property measurement. So I know that, say, for phonons, I wanted to work on graphenes, so I can click on that for a co-occurring concept and then find more information. Now, this isn't the only kind of information available on Knovel for my students. There's also a lot of information on the kind of analytical chemistry or physics that I'd be doing in a laboratory. So for example, I know from graphene that I'll be doing a lot of work on X-ray diffraction. So I can click on X-ray diffraction and then very quickly learn how that technology is used. Right, so here again, I can look at this and find a book that maybe I think is of interest for myself here, so membrane and membrane technologies, and I can click in and then find that information. All right. So that is mostly everything that I wanted to show here today. I hope that it's useful for you, and I hope it's useful for your students. And, you know, again, if there are any questions, please feel free to ask them. And with that, I'll pass it back over to Kim.
Great, thank you, Chris. So hopefully this gives everybody a great starting point to begin reflecting on how you can start building out your personal network and strengthening your research. What I'm going to do now is just launch another quick poll to get feedback from you guys about what your thoughts are now. And then what we'll do is move on to some questions from the chat. So. Oh. Let's see. Sorry, here we go. Here's the new poll.
And please feel free to ask any questions. I'm, you know, really happy to answer anything about my time on time as an undergraduate researcher, things that I found that were useful, running research labs like this for undergraduates or getting them involved and engaged. Happy to answer anything you have.
Okay, we're about 56% voted. I'll give it just a few more seconds before I end it. Okay. And so let's see, so we do have some questions there in the chat. Let's see. So we do have, how do you work with librarians on undergraduate research mentoring?
Yeah, so, you know, that's a really great question. So we used to regularly have librarians come into the classroom and actually give a course on, or not really a course, I should say, but they would teach one of the courses, so one of the sessions that we did in our course on research fundamentals for students. So it's one of the things that we often hear, again, from our corporate clients, that they wish that students were a little bit more ready to do research on their own, or kind of run their own projects and things after they leave. And so we at, when I was at Northeastern at least, and also UNH, they would do this for us as undergraduates. The librarians would come in about once a semester and teach a course to us at the beginning, where they talked about, these are the tools that are available to you at this school. This is how you can actually use them to do research for yourself. And then also when we were working on research projects, the librarians were, just instrumental in helping us get access to that information. So anytime I had a question that I needed help with, or anytime I had trouble finding a piece of reference work, they were always really useful. So we just tried to make it clear to students that this resource was available for them. They wouldn't have it forever, and to make use of it while they did have it, because it is very powerful for them. And you librarians are very helpful.
Great, thank you. Okay, there's a couple more. It says, I have a classical paper. How can I find papers which cite this paper?
Yeah, so that's a really great question. There's a couple of different ways to find that information. So the way that, one of the ways that you can do this is, for example, and let me just pull back up the tool here. So one of the ways, for example, is, let's say you have a very, very famous paper, right? So I'll just search for, say, Korma here, because he's a famous researcher from the field that I was working in before, Avelino Korma here. So I'll limit it to him, and then we can look through the work that he's doing. So here, for example, if I go to his oldest work, I can look at some of these. And so maybe I'm interested in, say, this one here, right? Zeolites and organic reactions. So I can click on this. So the first thing I can see here are the citations, so where it's been cited from. So this has been cited 37 different times. I can click in here to see details. Right, for example, so here I have all those details there, where it was cited from and everything else. But I can also see, if I look deeper down here, I can see this article has been cited 37 times in Scopus since 1996. And so I can go through here and click on that 37 times, and then take a look at the times that it's been cited, for example. That's one way that I can do that kind of information, or that kind of analysis. So yeah, really good question. Thank you for it. So it looks like another question we have is, can you elaborate more on classification codes, their applications? Yeah, absolutely. So the way that I like to think about the classification codes is that they are a higher level of taxonomy than the controlled vocabulary. So for example, if I search for nanotechnology, you'll notice, so there's controlled vocabulary, but then there is also, and let me just close these so you can see them a little bit clearer. There's controlled vocabulary, but there's also classification code. Now, if you notice, the controlled vocabulary is much more specific. So it's things like, thin films, morphology, silica substrates, the type of semiconductors, all these other things. However, if I look at the classification codes, those are a bit more broad, right? So the way I like to think about them is actually in terms of zoology. So for example, a domesticated short-haired cat is a very specific description of an animal type. However, feline is a bit higher than that on the hierarchy, and then carnivore is even higher. The classification codes are kind of those high up categorizations in the hierarchy of taxonomy, whereas the controlled vocabularies are much more specific. So you can see here, right, inside of these classification codes, we have nanotechnology, but then solid state physics, chemical products generally, inorganic compounds. Those are much more broad, so they're a little bit more, they're applicable to more things, and they're a little bit wider. So the way I often tell people to search is, if you're gonna start faceting, I would start faceting with, say, the years that I'm interested in, and then also the years, the country that I'm looking for, and maybe the affiliations. But if I'm running a search for, say, research work, I would start with the classification codes, right? So for instance, maybe I know I'm interested in crystalline solids in terms of nanotechnology. And then within that, I would use the controlled vocabulary to learn specifically what about nanotechnology and crystalline solids is being done. So what kind of work is going on? And I can see here, there's a lot of stuff on single crystals, thin films, carbon nanotubes, zinc oxide, X-ray diffraction, self-assembly, silicon, right? So that's the way that that's the way I use the classification codes, but really good question, thank you.
So Chris, we do have another question from Jay, not in the chat, sorry, in the Q&A section, but we only have about 2 minutes left. I don't know if you can cover really quickly how to encourage students to have patience and learn the different features in EV and Knovel before we wrap up.
Yeah, so honestly, I think that part of that goes with the undergraduate research work. So it's almost more, so I like to fish in my spare time, and one of the things you learn in fishing is that sometimes it's not as much about encouraging the fish to bite as it is to finding the most amount of fish, or finding where the fish are, right? I'd say something similar with students. The students that you really want to look at to give tools like this because they are going to be motivated to use it are the ones doing undergraduate research, the ones who are thinking about going to grad school, the ones who are hoping to present at conferences and things. So while I don't have a really great idea on how to encourage students who are just trying to get through and get their degree and stuff on how to use these tools, I do think that you can really, as a starting point, target those students who are really highly motivated to begin with. And then frankly, if they find it useful, they'll tell their friends, they'll tell other people. So I think it's a great question though.
All right, so that is all we have time for today. Thank you all for attending. We'll be holding webinars each Wednesday and Thursday. The next session that we have is Knovel 201, Going Beyond the Content. If you would like more information or a link to the recording for this webinar or the recording for previous webinars, please don't hesitate to reach out to your designated customer consultant or directly to either Chris or I. If you're unsure of who your customer consultant is, let either Chris or me know, and we can send you that information. Our contact information is here, as well as the schedule for the current webinars remaining in the series. So thank you again for your time, and stay well.